I'm Gavin Clark with the National Museum of Computing and Reading Museum, and we're interviewing former employees and customers of Digital Equipment Corporation as part of the 60th anniversary of DEC opening its first office in the UK. It's June the 18th, 2024, and we are in Reading. I'm here today talking to Shaheed Haque. Shaheed, let's start with the basics. Please, first of all, tell us your full name and your place and year of your birth.
My name is Shaheed Reza Haque, and I was born in what was East Pakistan in 1962. My parents moved to England to study in 1964, and I came along as a 2-year-old.
And just tell us a little about your parents. So they came here to study, and what were they studying, or what was the
So,
family upbringing like?
so my father was from an agricultural family, and really nobody before him had ever even been to college. Or even really high school, but he sort of broke the mold and went on to university in Dhaka, and he was by reputation, did very well at university there, and got a very prestigious job in the Pakistan Civil Service. But ultimately, he came to the conclusion that his career trajectory would be limited there, so he decided to come to study further here in the UK. And that was the reason why we came over. As I said, we came in 1964. We lived in the Angel Islington very briefly. Then we really lived a spiral from the Angel Islington down to Bethnal Green, and then round the houses towards North London. And as an immigrant family, we were both welcomed in the UK, but at the same time, it was the time of the National Front and so forth. And living in Hackney wasn't, anything as salubrious as it is now. But we had a happy childhood. The school I went to, Brookhouse School, we fondly regarded it as the second worst school in Hackney, so we were quite pleased about that. I don't know what the demographics really were, but there weren't very many ethnically white people there. I remember that. There were a lot of Afro-Caribbean friends, a few, English people, and a tiny, tiny minority of people on the subcontinent. But I was blessed to have teachers who I think grew up with the comprehensive ethos that I think sort of came out of maybe of the 1960s. And I had several really amazing teachers, my maths teacher, my English teacher. I remember a particular geography teacher that they maybe saw something in me that I didn't know to look for or see. And so I actually had a brilliant education. I did very well at O levels, and that led to an entree into an Oxford University Access Scheme, which was very groundbreaking, I think, at the time. And so, a few short years later, I found myself as a working class immigrant brown boy, almost completely out of my comfort zone in Oxford University. Leafy halls and all.
So let's go back. What were your kind of, at school, you said you kind of, it sounds like you had a rounded education. Were these subjects you kind of particularly liked or excelled at?
I was good at everything except I was terrible at sports. So I had a third year report from my sports teacher, which was the worst report I've ever had, saying Shaheed has absolutely no ball skills whatsoever. But everything else was good. So I liked school, I liked teachers, I had good friends. Even the local representatives of the National Front, they say for some reason they took a shine to me. And so I had a lovely childhood.
And what about sort of personal interests?
So I was anything to do with science, rockets, planes. Electronics was barely a thing, so electronics didn't really figure until I was 16, 17. But the one sort of technology I didn't like was cars, because you got your hands dirty. But everything else, Marie Curie, Heisenberg, and my dad used to make me go to the library every week, and he had a fixed thing that we were allowed 4 books, and I had to get one book on geography or history, my choice, another book on science, and another book on biography or something like that. And then the fourth one was a free choice. And I just lapped it up every week. I'd go to the library, I'd get 4 books, and I'd be finished, before I went back next week. And I just read everything, So, I owe that to my dad. He made me do that, and I took to it like a duck to water. And so I think I was always hungry to read and so on. So that just worked out.
So it's an interesting time. So the 70s was a very kind of turbulent time, of course, in British history. And you mentioned the National Front. What was the kind of feeling you kind of get, the opening to Oxford comes up? How does that kind of come about?
So Brookhouse School was comprehensive. And as I said, actually, I didn't really notice the National Front really so much at the time, perhaps more in retrospect as I grew a little bit older and almost leaving school. But we were used to seeing post-World War. There's still bomb sites in and around that area. There were still places of corrugated iron sheeting that were sort of walled off because behind it there was a bomb site. And slum demolition was going on in the streets around where we lived. And the National Front, because it's on television, I sort of have vague memories of black and white television with National Front and left-wing opposition, fighting it out. So I wouldn't say I was terribly politically aware, but I was dimly aware of that. And of course, at school there were some skinheads. As I said, for whatever reason, they took a shine to me, but they didn't like most other brown people.
How did they take a shine to you? They just liked you?
I just don't know.
Were they just actually nice to you, polite to you?
Yeah, and I remember, I remember them sort of fighting other people because they were attacking me. I don't know, just the most bizarre thing, but at least that's the way I remember it.
So Oxford came up, and that was a deliberate application of your parents, or how?
No, that was. So my dad, bless him, said to me, when I took my O-level choices, he said, if you want to go to Oxbridge, they need a modern language. So when I had to choose between chemistry and French, he made me take French. And that was an amazingly prescient choice, because a couple of years later, the Inner London Education Authority, as it then was, they ran a sort of an Oxford Access program with 5 or 6 Oxford colleges, and they basically scouted, 20 odd people from across London to go up to Oxford and have a day of interviews and so on. And there's actually a whole process which we perhaps need not go into, but at the end of it, you ended up in Oxford for some interviews, and if you got through those, then you were offered an amazingly low offer of I think it was a B and 2 Cs, or maybe 2 Bs and a C, which is a ridiculous conditional offer for Oxford. And anyway, that's how I ended up there.
And what did you study?
Engineering science, of course. So I knew I wanted to be an engineer. And Oxford's approach of teaching you to be a generalist without me really understanding what any of that really meant, that was absolutely the perfect choice, because not only does Oxford give you a sense of self-confidence and ability, but you come out thinking that actually you can solve any problem. And that self-confidence, I think, is what landed me the job offers that I had coming out of university, because I had, at a time when many of my colleagues, even from Oxford, were finding it difficult to get job offers, I had 4 or 5 job offers.
So what were you applying for?
Electronics in some form, computing specifically. Britain at the time still had, the Cold War beneficiaries of sort of Raycom Mobile Cal and Ferranti and GEC Avionics, and of course there were a couple of these American outfits. There's IBM down in Winchester, Hewlett Packard in Bristol, I think, Digital in Reading, and the high tech scene was crying out for people to do amazing things.
So who did you interview with? Who did you apply to?
I applied to IBM. I think Capgemini in London was a software consultancy. ICL was in Bracknell. I applied to them. IBM Digital.
And you had interviews you told me it's the story
I had offers from Capgemini, IBM. Can't remember ICL. Maybe they offered me, maybe they didn't. And Digital.
And what was the job position you were applying for, specifically at
Graduate
Digital?
engineer.
Graduate engineer.
Yeah.
So you described the scenario well, but you'd gone for an interview at IBM, I think, and it was clashing with a DEC interview, wasn't it? So tell me.
So a nice little anecdote. So IBM had this amazingly glossy graduate engineering program, and they had these lovely brochures that were printed on heavyweight paper with cutouts. You could tell the production values are amazing, and they had this whole program. And so I had this interview booked, and they put us up in a really nice hotel in Winchester. And I remember driving into Hursley Park. They took us by minibus to Hursley Park the following morning. I remember I'd never seen a pheasant before, and I had to ask, what is that bird that's running across? So as we drove up through the grounds, to be told it was a pheasant. Anyway, so Digital was a bit more scatty, and they rang me up, I think, the day before or a couple of days before the IBM interview, which had been booked for weeks, saying, "Oh, can you come for an interview on so-and-so date?" And I said, "Well, I won't be able to make it physically because I'm in Winchester the previous day." So they were a bit kind of unsure what they could do, whether they would be able to interview me a day late, because they also had a graduate program. But I happened to mention that to the folk at IBM to see whether my interview could be perhaps rescheduled there. They said, "Don't worry, we'll take care of it." And taking care of it meant that after the interviews at IBM, they put me in a chauffeur-driven taxi and drove me from Winchester to Reading. And of course, I was sat there, in what felt like a limousine. It was just a regular taxi, I'm sure. I don't remember, but I'd never been driven anywhere by anybody. So I felt very warm towards IBM. Let me put it like that. So DEC actually had quite an uphill battle, because I was, blimey, IBM is amazing. But somehow the interview, the people at DEC, I guess the psychology of them being number two, something about that appealed. Anyway.
How did the interview go? What was the process, and how did it differ to IBM?
So IBM was amazingly well organized. I remember, there was, just for the interview, there was an ante room. There were 20 odd people there. The guys came. They took us one by one. We interviewed, and I remember I was actually there with a friend of mine from university. And after my interview, I came back into the ante room, and the guy I interviewed, he said, "See you later, Shaheed." And you could just see the jaws drop of lots of other people in the room because it had gone so well. Whereas at DEC, we stayed at the Post House Hotel, which is not quite the hotel we'd been staying at Winchester. And I don't remember too much about the logistics, but I remember one of the gentlemen I just had lunch with, actually, Mike, he was a senior manager there, and he interviewed me, and I knew the point at which I was going to get the job offer, because Mike asked me one of the sort of standard questions about how you troubleshoot a piece of electronics. And he said, if you've got a transistor radio and you're getting no sound out of it, can you explain how you would go about diagnosing that? And the standard technique would be to sort of figure out, okay, here's the signal path, start in the middle, see if it's working there. And if it is working there, then you can go to the right. If it's not working there, you go further to the left. And you sort of binary chop your way to a solution. So I remember saying to Mike, that's what I've just told you is the standard, but that's not how I would do it. I said to him, I would use my experience and knowledge to assess where the likely fault might be given the type of hardware involved, and I would take a guess there first, because if that guess proves to be right, I'll have solved the problem in one fraction of the time that anybody else doing a binary chop. But what I would do is, if that guess didn't work, I would fall back to the process of a binary chop, and I think that's what got me the job, because it showed that I knew how to follow a process and be diligent and find the solution no matter what. But it also meant that I knew how to take a shortcut, and I think that was the DEC way. You sort of saw the problem and you tried to find a lateral solution. You didn't necessarily follow the textbook.
So what year did you join DEC and how old were you?
That would have been 1983, so 21.
And you came to Reading?
I did, yeah.
And whereabouts what was it Reading like at this point?
Oh, Reading was a laugh. Before I'd gone up to Oxford, I'd never lived outside London, certainly not by myself, or really, I'd barely been outside London. So at Oxford, I became used to the idea of, students putting on productions and plays and music and lots of things to do in the evening. Every evening there'd be several things you could do, or parties at people's house, whatever. So when I came to Reading, obviously I knew things were going to change because I was now in the world of work. But I remember thinking to myself, well, Reading's a university town, so when the students turn up, it'll be lively. There'll be all this stuff to do. And I remember I had this distinct memory of it being in November, and me suddenly realizing, well, the students had been back for probably 6 weeks or so, and I hadn't heard a peep. So what was Reading like? So Reading, Broad Street, I think I might have said this before, Broad Street at 6 o'clock felt like tumbleweed would blow down. I think I used that phrase with you before, but yeah, that's how Reading felt. I lived on the hill just to the south of the city centre. At the very top of the hill, there's a roundabout, and I lived in a block of 4 grade 2 Georgian houses just along there. They're probably still there. But that walk from Broad Street to the top of the hill, it felt like going from, the back of beyond to, my goodness, right out in the sticks, because it was so quiet, absolutely deathly quiet. But the flip side was, you spent a lot of time at work, right? And DEC had an amazing canteen, so you'd have lunch there, and you barely needed to eat in the evenings.
So that's interesting. So because I'll come on, that sounds like DEC Park, which is described there. But you were at CSS, I think.
No, I was always in engineering, proper engineering. CSS was sort of custom stuff,
Right?
Low volume stuff. But I was never interested in that.
And what buildings were you in at this point?
Okay. So when I started at DEC, our part, which was European Distributed Hardware Engineering, EDHE, I think we were called, European Distributed Systems Hardware Engineering. We were in Acre Road, which is just this side of DEC Park.
And what was the building like?
It was terrible.
Right.
It was this what was very fashionable, this coloured pressed steel construction, but I guess it was an old warehouse or something that had been converted. It felt, I don't know the real history, but it felt it had been converted into offices hastily. So in the summer, it was as hot as anything, and in the winter, it's absolutely freezing. So we were all very grateful when DEC Park 2 was eventually built, and we moved somewhere nice.
And what was the surrounding area? That office, was it residential or commercial?
No, Acre Road was just off the old Basingstoke Road, and it was on the left-hand side. There was the park. I don't know what it's called. There's a big green space there. But on the right-hand side was a light industrial estate, which leads all the way up between the top end of Basingstoke Road and the bottom end. There's a light industrial park along Rosekiln Lane and down. So it was all light industrial.
And
I think Raycol Mobile Cal was there amongst others.
And what was the work atmosphere like in this particular building this time? Was there anything? Was there a sense of camaraderie or fun, or what? Describe it to us.
So I was thinking about this because I thought you might ask me this. I'd say it was a collegiate atmosphere. I couldn't have articulated that at the time. So it was pressured, but most of the pressure felt like it was self-imposed. So the first project I worked on was a thing called DMB 32. I started that project 6 months into my time at Digital, maybe 4 or 5 months, something like that. There were 5 or 6 of us on the team. We were building an I/O board for a new generation of VAXes. So this was absolutely bleeding edge technology. So for me, it was very exciting. You were conscious that you were working on something that was very sexy and very cool. And of course, I knew my friends from university, and I knew what the sorts of things that they were working on. And I loved what I was working on.
What is DNV32? And for those people who don't know, what is an I/O board and why was that important to VAX?
Okay, so if you buy a computer sitting by itself is absolutely useless. You have to be able to either put data in or take data out, or do something with the output. So first of all, that explains input output. If you have a computer and it has no IOs include keyboards, it includes printers, it includes all that sort of stuff. So if you have a computer and it has no IO, the computer's pointless. Okay, so that's the significance of IO. In this particular case, the new generation of VAXes, so digital carved its unique niche in the history of computing because it democratized computing from the big mainframes that IBM and Burroughs and the like were making into much smaller, more affordable systems, as you know, and VAXes were the next step in that. But the VAXes that I was working on, the 11780 was a generation of technology that you might think of as made of what you would describe as small-scale integration. Each chip that made up a VAX was typically had 8 to 10 gates in it at most. So you had a board full of stuff, and all the chips on it were very, very what we call small-scale integration. The 780 went through a couple of generations, but the generation that we were working on was the first generation of what were called CMOS VAXes. So this was a new technology, whereas previously all the technology was what's called bipolar. Fast for the time, but very power hungry. CMOS was seen as a way to get much higher density at much lower power, but not all that fast to start off with, okay? But that was going to enable VAXes where the power supplies were only several cubic feet instead of wardrobe sized. And so that was the generation of VAXes. So the CPU, so a typical 8200 would have been a half height 19-inch rack. One rack with the bottom would be power supply. One rack would be the actual main chassis. The main chassis would have maybe 14, 15 slots. One slot would be a card this size for the CPU. There'd be a couple more cards for memory, and there'd be more cards for I/O. So mine would have been one of these cards. And again, I've explained what I/O is. So in this particular case, the I/O you could connect to a DMB32 was you could connect to a printer, a high-speed printer. You could connect 8 VT100 or similar terminals or serial ports or modems, and one high-speed 64,000 bit per second modem for wide area communications.
This is big for stuff today, but you would pretty much take for granted and would think that stuff would come built in, wouldn't you? But at those days,
and 1,000 to 1,000,000 times faster than. I mean, today we talk about gigabit speeds, and Here I'm talking about serial ports that operated at 9,600 bits per second, and now we're talking, your phone will have a 5G connection that can maybe do 1 billion bits per second.
And you're dealing with large pieces of hardware as well. It's not small by any scale. It's compared to what's gone before, it's small. But
Yeah.
what do we have today? It's huge.
Yes. So a DMB32 card, it's this size, packed full of chips, and those chips were, tens of times more powerful than the 780s of the previous generation. The DMB32 in particular actually had a microprocessor on board, so this was a novelty. I mean, before, previous generations of all the work was done by the main CPU. This was really the first generation where there were small single chip processors actually on the I/O board itself that could offload some of the work from the main CPU. So these are very different, technically speaking, than our predecessor cards.
So very much, and are you still a graduate at this point? So do you have a job title, portfolio, or are you still very much the graduate in the team? What are you at this point?
So for the DMB32 project, it's about 3 years long, probably a year and a half late. But Mike, Rickwood, and myself, we were the two grads. There was Mike and I had a supervisor. There was one guy did firmware, another guy did software, and we had our manager. So it's about 5 or 6 people.
And but they've thrown you in at the deep end on this, haven't they?
Yeah, and honestly, we were trusted. So the DMB32, the I/O on it was supposed to conform to this whole list of standards: X21, V24, V28, RS232, RS423, RS422, V35. And nobody had realized. So I was told you need to design it to support these things, and nobody had realized that each of these needed a different kind of cable at the back. And actually, there was no space to have all these different cables. So at some point, I remember going to my manager, and Dave, and saying, look, I can design a circuitry for all these, but we can't physically connect the cables. There's no space because all these need different cables, and they had no idea. So, they'd told me to build something which couldn't possibly be built. And you might have thought that a senior engineer might have made that decision ahead of time and not told me to build something that was not possible to be delivered.
So what happened?
So in the end, one of the guys, so I'd come up with a particular technique which I don't need to bore you with, for making sure that the cables that plugged in there were 6 identical gray cables that you plugged into the back. And these were on the end of what could be 12-foot pieces of wire, threaded through several computer cabinets. So you can imagine that those 6 cables would be very easy to confuse. So I came up with a way of making sure the cables were plugged in correctly. And one of the more senior engineers, Andrew, he sort of took that idea and he worked out that there was a way to have one cable which itself could have different adapters at the end, but it could tell the board what kind of cable it was, and therefore whether to run X21 or V35 or whatever. So it was a combination of stuff that I had invented to make sure the wires weren't tangled, with an idea from Andrew, and they came up with this adapter cable, which became known as the 50-way sync connector, which was then used for generations of product, both for digital and our competitors. And we just took that for granted, because it was a problem that needed solving, and we solved it. There's no big drama,
And so at what point, so you're still in the graduate, at what point do you start becoming sort of employee job title? How does things start picking up from there?
I don't remember the details, but it's very quick. And, I was getting amazing pay rises.
What kind of, you said like you were getting 17 to 20% pay rises? On what basis? Like, as a matter, every annual?
Every year, yeah. I remember at one point I briefly considered going back to the University of London as a research fellow, as a research assistant to go and work on some computer sciencey stuff for one of the professors there. And it was a really exciting project. But then I realized if I go into academia, I'll be stuck on academic 1% and 2% pay rises. But at DEC, I was spoilt, with these. Um, so that was so. There was a trajectory from graduate engineer to senior engineer, principal engineer. But actually the hierarchy was actually quite interesting. I mean, technology companies today, you think about the behemoths of the industry, they have very, very broad triangular routes to the top. If you're an engineer, the routes tend to be more like this. But in UK industry at the time, let alone for somebody with a brown skin, the routes were like this. As a senior engineer, you couldn't be on a CXO level, but digital offered that. At digital, uniquely compared to its British counterparts, if I became really the topmost level at which you could have a normal promotion from within your group was principal engineer. Beyond principal engineer was the hallowed realms of consulting engineer. Now, to become a consulting engineer, it had to be the case that it wasn't your group that promoted you to consulting engineer. Other divisions within the company had to be able to stand up and say, even though Shaheed doesn't work for us, Shaheed's made enough of a difference to our business that it's moved our needle. And they had to support you. So it was that level at which you had to have consensus from other groups that you were good enough to be a consulting engineer. And so even to have such a route available was unheard of. There was no such thing in British industry.
And were you being pushed forward by management? Were you on this, like many people at DEC tell us how they kind of, management looked out for them, was like looking for them to make the next opportunity or leave. Did that happen in your experience?
I think I was probably an arrogance. So I just had infinite self-belief, and I worked with amazingly bright people. And perhaps without me really recognizing it at the time, perhaps they pushed me, I don't know. But I mean, I just lapped up every challenge that came along. So my career trajectory was good.
So where did you go after this? How did it?
So after a while in hardware, after not very long in hardware, I realized that the writing was on the wall, because there's this thing called software was coming along. And I sort of suddenly realized that actually hardware, see, the industry flips between putting most of the smart stuff in hardware and putting most of the smart stuff in software. And that used to flip every generation for the first few generations. But now nearly everything's in software. Okay, so that's why there isn't such a call for hardware anymore. And everything's done in software. But at that time, there was still this flip-flopping. But I sort of suddenly realized that there was this big flip about to happen, and no one was going to build hardware anymore, or there was going to be much less need for hardware. So I made the flip to, first of all, design tools for hardware, and then ultimately I moved into just pure software. And partially, I think, because of the nature of my interest in sort of broad technology as a non-specialist, as a generalist, moving from the hardware group to the group that supported the hardware, it was very controversial. I remember quite a few people said to me, why would you go into CAE? That's much less sexy. But I said to them, you're going to be out of a job. And I'm going to be building the tools that will put you out of a job. And that's what we did. So, again, without knowing that we were doing stuff that was novel, even today at lunch, people remembered the packages that I built to help them design chips, because now those packages cost millions of dollars, and at the time I built that first tool for our group and I didn't even know it was worth remarking on.
So come back to, so the career is going well, and do you mentioned how your other graduates were out there in the industry as well. Do you ever compare yourself? Because you mentioned the huge salary, the promotion, the salary
So
bumps that you were getting
I
as well.
remember my best friend from university, he got a job at ICL, and it was a good job. He was helping designing their CPUs for the 29,000 series or 2900 series. And he had an amazingly interesting job as well. But my salary outstripped his very quickly because ICL were paid British rates, and we got the rises that I mentioned. So I don't really know how DEC decided what to pay because they certainly paid way and above anybody else. And obviously I'd meet friends from university and so forth, and you didn't necessarily talk salaries very much, but it was pretty clear that I loved my job and many of them didn't like their jobs.
What was the workplace like? We talk about the very collegiate work style, but we hear a lot about kind of the social aspect and the friendship aspect. So what was the working environment like from a kind of, I suppose, social and kind of human perspective?
Well, I think we talked about Reading being very quiet, and I'd come from this amazing university town, and it was very friendly. It was very, very friendly. There's no real sense of hierarchy. Of course, we knew who the senior managers were, but that didn't mean we didn't go to the pub every Friday with the guys to have me and Muslim, right? We'd go every Friday to the pub in Risley.
What was the pub you went to?
The Bullet Risley, I think. Yeah.
And that was
And then actually every evening, to be on the DMB32 team and work for Dave Fenwick, it was essentially mandatory to go to the Swan at 3 Mile Cross every evening. So that was interesting. Again, I didn't drink, but
what are you doing? Just drinking soft drinks, hanging out?
Just drinking soft drinks and hanging out with the guys.
And the other guys are all getting drunk.
No, I don't know if they drank a lot, but they didn't get drunk. They seemed to hold their drink pretty well. And Dave drove this very sexy Ford Capri 2.8 liter something or another, and Rob, my supervisor, had this drop top Volkswagen Golf Mark II, and it was very much boys. Girls were virtually non-existent. There were two girls in the graduate group of maybe 25 people, but none of them in hardware. Hardware was hard. The only feminine touch in hardware was our secretary, whose name temporarily escapes me.
So those in your year, so two women in the whole graduate intake for that year.
Yeah.
Did you notice women in other parts of DEC around?
So it's funny because when we eventually moved into DEC Park 2, DEC Park 2 was separated from the main DEC Park 1 building and the canteen by a glass tunnel. And I remember at lunchtime we would emerge from the tunnel from DEC Park 2 into DEC Park 1, and there was this sort of, you could see some of my, let's say, less socially capable colleagues' eyes widening at the sudden notion that there was a mixed cohort of people out here in marketing and the normal part of DEC.
Describe, so that's an interesting point. So you've moved over from the older buildings to DEC Park 2. What was it like? Because the old building sounds like a very dark and uncomfortable place to work. What was DEC Park?
It wasn't. It was. The amenities were okay, but it was uncomfortable. Okay, so we all had nice cubicles, 2-meter high walls, and all the rest of it, and that was very much unchanged when we went to DEC Park 2. But DEC Park 2 felt like, it was a purpose-built place, and there was as opposed to the small but friendly canteen we had in Acre Road, where we knew the kitchen ladies. At Deck Park we didn't know them, but it was an amazing place to have lunch and
What was
so
the canteen like?
You had a hot meal for almost no money, but really it wasn't so much the canteen, it was the environment. You walked out of, so Deck Park 2 was a traditional deck engineering place. Everything was grey. All the colour was grey, the carpet was grey, the partitions were grey, the people were grey, okay? But when you went through the tunnel, you emerged into the sunny upland of Deck Park 1, and the carpet was green. It was a sort of faux grass, and there were plants. We had a couple of token plants in Deck Park, but no one cared about those. But the ones in Deck Park 1, and there were bays of people you could see. As I said, there were women there were men there, and they were obviously working together. And this was like blimey. So I can remember laughing at some of my more singular colleagues as they emerged.
What was the? It's interesting you described Deck Park 2 as grey, because it was supposed to bring people together. This Deck Park concept was supposed
Rubbish.
to bring everyone together.
Oh, it might have brought us together because physically in Acre Road, software is mostly upstairs and hardware is mostly downstairs. This is a small building, and there we were all on one floor, but they were on the other side of the corridor and we were on this side of the corridor. So I'm not sure. I'm sure the architects thought this was all bringing people together and collaborating. But there's a load of rubbish, really. I mean, we all collaborated. We all knew each other. We went to the pub together. We chatted about projects and we chatted about other things as well.
Did it change at all by coming to Deck Park 2? Did that loosen things up, make it easier to get on? Or you maybe talk to business people?
We never talked to.
Did they come down and talk to you?
No. We don't talk to business people. Deck Park 2 is engineering. Okay, so we were still engineering. We still didn't talk to anybody else outside engineering. Maybe the managers did, but we didn't.
And just describe the canteen. What was the food like? Do you remember anything about the food in the canteen?
It was very, very good.
What did you get?
I can't remember now, but it was a proper cooked lunch. I mean, Acre Road was fine. We knew the ladies. There would be a couple of things for main courses and a couple of desserts. But at Deck Park, you could have salad. You could have, there were 4 or 5 desserts. You could have, I can't remember now, lots of things. It felt like, a restaurant. It felt like a restaurant. That's what it felt like.
And were you ever aware of we heard about senior management, Jeff Shingles, John Barrett, all those guys coming down, moving amongst you?
We knew those names, but you see, we were engineering. We were much better than these lowly country people. See, engineering in Deck. So CSS is special. CSS was custom stuff, small stuff. So we never really looked at them as proper engineering. Proper engineering was about high volume worldwide engineering. We built products to be sold internationally on a large scale. The part numbers that we had, there'd be UK variants, German variants, French variants, whatever. So we were aware of the business people in Deck Park 1, but we reported up through US reporting chains, through US engineering. So we really had very little to do with Deck Park 1 from a organizational perspective. I laugh about them, but of course they were important people. They sold the products and all the rest of it. But
just how much influence did you have on worldwide engineering then? Because interesting, you mentioned, I've heard this before, that your group reported up to US. I mean, you're based in Reading, and yet your reporting structure is different. How much impact do you think you being based in Reading had on, I suppose, global product?
It was interesting because initially part of the rationale for setting us up was eventually, I guess, they just started to run out of talent that they could hire in the Massachusetts area. And I assume that was one of the reasons why they set up. But also there was a pool of very specific British and European talent that could be had. And there were European problems that could be solved. For example, the group originally, before my group took the direction it did, its product lines were modems. And modems in those days were very, very country specific. So really the first generation of standardization was happening, but still one would have to take the modem through German regulatory approvals, French regulatory approvals, British regulatory approvals. So there's a whole setup needed to take these telecommunications products through the regulatory processes of each individual European country, let alone Japan. And I guess Japan and Europe were the main places. And the Americans, bless them, they were barely aware of anywhere outside North America. So for whatever reason, a large part of the rationale was, the ability to negotiate those international variants and so forth. But it quickly, I think, evolved from there, because I think they actually realized that there were some smart people over here on this side of the Atlantic, and that we could do stuff that perhaps they were less interested in. So that's, I think, how come our group became wide area networking, whereas our sister group in the US was mostly local area networks. And so if you look at the internet today, and you think of, well, actually the internet today is a wide area network, it's worldwide. So a lot of the protocols and so forth that weren't really primarily of interest to the local area networking folk in King Street, guess what? They were developed and, conceptualized in Reading, because we were the wide area networking people. And that's directly relates to our international geography, or derives from that in part at least. So it was half the rationale, I think, was that international relation, and half of it was just talent that could not be had in.
Can you think of an example of a WAN technology that you guys would have worked on that would have made an influence or would have come out of Reading?
So definitely, I mentioned that 50-way connector, and that's a small thing, but the internet today, the way service providers, your Vodafone or your Sky, or E3, EE provider, the way these service providers are connected together is with protocols, software protocols, or routing protocols. And Reading, and in particular a couple of guys in, not in my team, but who sat next to us, the architecture team for our group, they literally wrote those standards. So some of the ISO standard for what's called integrated ISIS, intermediate system into intermediate system. There are two flavors, one called OSPF, one called ISIS. And ISIS was written in Reading by a couple of the guys in our group.
And how did that change things in its own particular way?
You couldn't have built the internet without that. It's really as fundamental as that. So the basic understanding of how you take disparate companies like France Telecom and British Telecom and get them to cooperate to transfer data from Hong Kong to Boston, nobody had really worked that out before. So the internet today, as you see it, wouldn't have existed without those things.
And it's an important time, because DEC, which has always been a networking orientated company, is now thinking beyond just networking of its own products to more of its own products, to networking to other people's products.
Absolutely.
And this is the way the world is starting to turn at this point as well, isn't it?
Yeah, exactly. And I mean, I'm sure there are other examples I could think of, but before TCP and IP came to rule the world, the networking standards were really defined by international former telco committees under the auspices of ISO. And DEC played a big part in those ISO standard settings, along with the likes of IBM and Hewlett-Packard and all the rest of it. So although I said that some of these standards were written by the guys there, I mean, they were collaborating with these other companies, and they were in the subcommittees that took on responsibility for those things. So I'm not saying that it's 100% our work, but they were the lead authors, and
they were the DEC's leads on those committees.
Absolutely.
Yeah, I understand that.
And ultimately wrote those standards. Yeah.
So tell me a little bit about, we've discussed a great deal of technology there, and one of the things that's come up is clearly there's this thing called the DEC way, I'm not sure how much you're familiar with this, because we have discussed this big discussion about the deck weight means different things to different people. I'd always be curious to find out what people understand that to mean and how far it filters down to them. Were you ever aware of this concept called the deck weight?
Yeah.
What does it mean to you?
Do the right thing.
And what does that mean?
That means if there's a problem, sort it out. Don't try and hide it. Flush it to the surface, figure it out. Another way I would describe it as let's some of these things are very complicated. So obviously different people have different opinions on how things should be solved. So the deck way, or one aspect of the deck way, is you would go in to a room with a whiteboard with 2 or 3 of your colleagues, and you'd go at it hammer and tongs, criticizing each other's points of view and so forth. But at the end of it, somebody would say, well, actually I didn't realize that, and the other person would say, well, actually there's that thing that I like about what you did. And you were in there fighting hammer and tongs for your position and your idea, of course, because we're human, okay? But then to come out with a synthesis that you all signed up to and walk out smiling. I'm sure there were, I don't want to say it was all unicorns, but there was this idea that you could thrash things out. You didn't have to become an enemy of somebody to have a disagreement with them, and then resolve it. There was no need, you could all be winners by picking the right choice.
And did you ever see DEC obviously exhibited do the right thing by in terms of its relationship with its customers and its staff? Did you ever see that playing out? Obviously, you mentioned you're kind of like being a person of color, brown person in an educational sense and growing up in London. Did you know we discussed about DEC doing the right thing in its advance, an attempt to advance women through the structure? Did you ever see that in terms of color at DEC as well?
Not that I would remember. I can't think of any particular evidence one way or the other, but I certainly wasn't treated worse than anybody else. And again, it's not something perhaps I would have remarked on at the time because I was too stupid. But even now, looking back, I can't remember a time when I can remember being offended or upset or sidelined. I always felt like anybody else, and what more can you ask for, really? So I wasn't aware of that. It may have been that, for all I know, senior management were discussing about diversity, and so possibly. But I never heard that. I just felt part of the team, and I felt like a valued member of the team, and that was fine.
And what was the were you receiving things like many people got lots of training and sort of education and stuff. Did you receive any of that?
So that's an interesting question. I was talking to my son about this the other day. I don't remember getting. I remember getting on one training course for electrostatic discharge for a day. I don't remember DEC ever giving me any training. And when I was discussing it with my son, I said to him, well, the reason is easy, because we were the world experts, every one of us, at what we were doing, almost down to the graduate engineer. Okay, we didn't have the scope of the world, but you know what I'm saying. So who was there going to teach us anything? What were they going to teach us? The stuff that we were working on didn't even exist yet.
Did they give you training and stuff outside of engineering and technology?
I don't remember. I don't remember ever going on any financial or technical or presentation skills courses. I don't remember going on anything like that. I'm sure that within the UK organization, there was plenty of training. In engineering, I don't remember seeing any of that. So I would have liked to have gone had it been on offer, but actually I do remember one course. I went on a course about VAX internals, which was great, but that was it.
And do you have any you described the workplace culture? I asked you the thing to describe a great memory. You've just moved on to workstations, hadn't you? What happened with the transition to workstations?
So that was kind of interesting. The standard interface to a computer in those days was a thing called a terminal, VT100, DEC set the standard with the VT100 and eventually the VT200. These are things with a big old keyboard and a probably a sort of a 14-inch screen or something like that, monochrome, and ASCII and numbers, letters and numbers. That's pretty much all you could do, and some punctuation. But I was lucky in that I arrived just at the time where designs were outgrowing tracing paper and ink. And so this first project that I worked on, some workstations were brought in to do two things in particular. One was we had some custom chips on there, two custom chips, and that required these new workstations to be able to design things graphically.
And what is a workstation?
I'm sorry, a workstation was different. So a VT100 would be this sort of thing with a 14-inch screen, orange on black or green on black, text and numbers.
And it talked to the
it was dumb. It was dumb. It just talked through a wire to the VAX, through a wire that the DMB32 would eventually go on to provide. But the workstation had bitmap graphics, monochrome initially, and all it could draw was outlines of things. So a NAND gate would be this thin green outline, as opposed to like on a modern computer where your email client has colored backgrounds and fonts and all this kind of stuff. Everything was just thin green lines. But we had a thing called like a trackball. A mouse hadn't been invented. There was no such thing as a mouse. So we moved things around with this sort of trackball thing, and then we joined up wires and so forth. So that was a step beyond pen and ink.
And it's like a PC in a way, isn't it? A workstation, but very fast, very highly specified machine.
Yeah. And of the 4 or 5 projects that our hardware group did, we, the DMB32, we were the first project out. The 5 of us, well, in fact, the 3 of us that worked on the hardware, we were the first people to have those. So they were extremely. I don't know how much they cost. They must have probably several years' salary.
What was it like, the transition from pen and ink and paper to?
I only ever worked on the post pen and ink, but all the other groups are still on pen and ink. So I can only tell you what it was like on the post transition. Well, we could see those people wandering around with big rolls of paper and rubbers. And
they're still using those.
Yeah.
So tell me about. So you've been at DEC now. So you joined in '83. When did you leave DEC?
So I spent 3 or 4 years doing hardware, 3 or 4 years doing hardware design tools, then 2 or 3 years working in the software group that was next door. And then I moved into a group doing video servers. And that took me through to 1999, I think. I was at DEC 14 years, so 83. Must have been 87. Must have been 97. 97. And then I went to Oracle, where I was at Oracle for a while, and then beyond.
And what made you leave DEC?
Oh, DEC. I moved out of the networking group to the video server group because the manager that had originally recruited me into DEC, he'd come back from the US. He'd done a stint in the US. He'd come back and set up this new group, and it sounded like it was going to do an unbelievably sexy thing called video streaming. So of course that was, wow, that's got to go work on that. But then DEC ran into the buffers, and the first thing it did was get rid of groups that were advanced technology groups that were not making money. So video serving, this is 97, that was not a thing. So there was no profit to be made. So the team was disbanded. There was about 125 people in the group in Shrewsbury, in Massachusetts. And the 5 of us here in the UK, we were the EMEA rump of the Shrewsbury video server team. And when the group was disbanded, we were made redundant.
And during that time, you've obviously created an incredible amount of intellectual property to the company. Can you run us through some of the products you would say, yes, I've done these things or contribution?
So, funnily enough, I didn't really know what a patent was. So I missed out on a lot of patents, I believe, looking back. But at the time, I didn't really notice. Um, I invented a way of using those workstations to design things called state machines graphically, which was revolutionary at the time. I believe it's industry leading at the time.
What was that?
Is a program called G-State, which used the underlying facilities of these workstations to allow you to drag and drop and build a thing called a state machine diagram, and then run that through this novel thing that had only just hit the marketplace called logic synthesis, where there were tools out there from a company called Synopsys that could take a logical description of a piece of hardware and turn it into a gate level design, which could then be turned into a chip. And having the ability to do state machines were very laborious to design by hand, and they're even more laborious to tweak. If you decide to change the behavior of the state machine, I mean, during the design of a product, you might start off with a state machine that has several thousand gates. Imagine you then decide, we need to tweak that bit of functionality. Often, 20 or 30% of those gates would need to be redesigned. Compared to you walking up and saying, I want to redesign this. I'm just going to delete that box and put this other box, press this button, and a new net list is going to appear. So that was the difference. And I think that allowed my team to build 7 custom chips, ASICs as they're called, one after the other. And they're essentially all right first time, because most of the complexity in a chip is in the state machines. And the fact that they could use a state machine editor to edit the things graphically meant that, as I said, even at lunch today, somebody reminded me that I'd invented this thing. So that was, I was barely aware that I'd invented anything, but it made a huge difference.
It's remarkable. This kind of work wasn't patented, or...
As I said, I barely knew what a patent was. In fact, it wouldn't have been patentable because software patents weren't a thing at the time. But then there were all sorts of other things I worked on. The thing I'm most proud of, I think, is there was a router called the DECNIS router, which is the thing that I showed you this big thick architecture manual for. This was the world's fastest router several years running.
Fast? What was fast? We know that definition.
It had 14 Ethernets that could plug into it. And to put that into contrast, I mean, your house probably has 14 Ethernets worth of devices, from your Xbox to your Skybox to your oven to your phone to your wife's phone to your children's phones. You probably have 10 or 14 Ethernets worth of product. But a DECNIS was a massive box. I don't know how much it cost, but I can imagine a system might have cost you £100,000. When hardly any offices, maybe 0.1% of offices in the country would have had any kind of a computer, let alone a network. So to be the fastest in the world, just being able to handle that much capacity, that was groundbreaking. And I feel that I invented some unique technologies that made that system possible, in terms of the way that I/O was handled, in terms of the way that addresses were looked up. I could bore you for hours. But
and who would have bought that DECNIS? Type of customer would be what? Banks?
British Telecom, banks. Yeah.
What do they want it for? Just the speed of throughput or the bandwidth?
Yes. Let's say you have an office block, 20 stories high, and you've got, maybe 100 people on each floor, and each of them is sitting on an old style VT100 terminal. All those terminals have to connect to something, and even the way they connect in those latter years was being done through Ethernet. So at some point, all those Ethernets have to come together, and something has to be done with them. So that kind of thing was just beginning to emerge as a possibility. Actual wide area networking in the way that we think of networking as being ubiquitous today really was barely a thing. Now, I'm pretty sure that the senior people who posited the need for such a product, I'm sure they could see further than I could see, and they probably saw something like what we have today. But those things were not widely known or used around the world. You know, you'd have to be a very, very forward-looking organization with some very forward-looking requirements. I imagine, you know, the university networks, research networks like Janet, I imagine they would have had things like this. CERN would have had things like this.
So it's a way of consolidating traffic on the local network and getting it out over the wide area to,
for example,
and other organisations somewhere else on the other side of the city or something
absolutely.
like that. So you left DEC, you got the job at Oracle. Did working at DEC open any doors for you? Did they welcome you in?
It did. There's a funny story there. So the last thing I did for DEC, there's many things that I did at DEC that I was proud of, but one of the last things I did was I built the world's first, what's called an MPEG transport multiplexer. So before I built this thing, these transport multiplexers, they were very primitive, and they were boxes of hardware that cost, you know, many tens of thousands of pounds. And I built one using a PCI card that was a $500 PCI card that was custom built to my specification by some dudes in the back of a Dairy Queen in Wisconsin. And some software that I designed and built from scratch just by reading the MPEG specification. It was so, looking back now, terrifyingly, there was no test equipment available. This stuff was so new. There was there was nothing to test it with. And with all the confidence of an ignorant youth, I just went ahead and designed it because nobody told me it couldn't be done. I just built it.
This was your project, and no one at DEC told you?
So Mike, my manager, we won a video server project with Deutsche Telekom. Deutsche Telekom wanted to connect their cable TV network in the Bonn-Cologne parliamentary area with a bunch of MPs and ministers to a video server. But how do you get data out of a computer, which was one universe, into the television universe of cable networks? Such a thing had never been done before. So there was literally no equipment you could buy anywhere in the world that could take data out from a computer and put it onto a cable TV network until I rocked up and built this transport multiplexer. But I only built it because Mike said, we've won this project, can you build this thing? And I said, well, give me the spec. So I read the MPEG specification. I said, yeah, I think I understand it. And that was it. And so how we ended up at Oracle was that Bonn-Cologne Deutsche Telekom system led to a system for British Telecom and Sky and what was then Midland Bank and Argos, a weirdo combination, but they were going to do shopping over a computer through your TV using Sky satellites to deliver the signal, digital television to your TV. So Sky had just been launched. Midland Bank was in there for the finance aspect. Argos thought they were going to sell online, didn't even exist as a word, okay? And so again, we had the problem of how do you get the data and the video streams out of the video server up to the Sky satellite. Well, it turns out that the way you get video, MPEG streams out of a computer into a German cable TV system is exactly the same way that you get signals out of a computer up to a Sky satellite. So this card that I had built, the transport multiplexer that ran on it or ran with it, was the only game in town. So Oracle won the biggest ever contract they'd won in the UK for consulting as $100 million project of consulting, and they needed our video server. They had their own video server, which they sold into the contract, but they needed my video card from my competing video server group at DEC to make their system work. So although DEC lost the video server contract, they still won the hardware contract with Oracle. So they did this kind of a bizarre deal that I guess salespeople love doing, which is, well, we didn't win that bit, but we won the other bit. So yes, we'll give you Oracle, we'll give you that piece of hardware technology. So I worked very closely with our Oracle boys on this £100 million project. So when the entire video server group was let go at DEC, Oracle faced the possibility of losing their $100 million project. So mysteriously, the five of us in Reading ended up coincidentally on the same jumbo jet off to Redwood Shores for an interview. And so we were made redundant by DEC on the Friday, and we walked into Oracle on the Monday. Off the back of this one card that I had built, off the back of a question from Mike as to could this thing be done. And of course, that project died several years later, but that was a whole different story.
The DEC way is responsible for many paths. Tell me about, so you end up at Oracle, and obviously you're outside of DEC. You obviously see the company going down. What were your thoughts when it's finally the Compaq acquisition comes along?
Very sad. Oracle is a very, very different company. These companies, they all have a rich history. They all have stories that are told about their CEO. So, Ken Olsen, told stories about selling Vaxes and pushing Vaxes out of jumbos, and Larry Ellison, the Oracle guy, he was famous for being brutal. Apparently it wasn't enough to win; the other guy had to lose. That was the story that was told about Larry Ellison. The culture. So although I couldn't have told you what the DEC culture was when I was at DEC, when I moved to Oracle, I suddenly realized what the DEC culture was. Okay, and it was very different. Oracle itself was a great company to work for, and the team I worked for was an absolutely brilliant company, a brilliant group within the company. They were very close to Larry Ellison's heart. I nearly got introduced to Larry Ellison, so it was still a very special environment, and in many ways the video server team at Oracle felt like the team that I'd been with at DEC, but outside you could tell it was a very different company.
Different in terms of what? More competitive, more aggressive, less collegiate?
Much more commercial, aggressively commercial.
DEC didn't have that.
And that's probably part of their downfall, I mean, in all honesty. But I wasn't really senior enough to really be able to assess. I mean, I was,
So coming back to the question, so you see, you obviously you heard about or you read about Compaq acquisition. How did you feel about that?
Well, most of my friends were still there. I think the rot took a long time to really take hold, but it was pretty clear that the kind of stuff that DEC had built, and we were a part of that in terms of, defining new things, networking, low-cost computing, these sort of genre-busting kinds of ideas. It was very clear that Compaq was going to be dull in comparison. And then, of course, the eventual purchase by HP, that was the ultimate letdown / insult / whatever, how you want to describe it. It's clear that they were going to kill everything that was a competitor thing at DEC. And of course, we knew we were better than them, so, it felt awful. But, I was out of there, so I could afford to not care as much, but you could see the people who are still there. And a lot of those people, we didn't scatter to the four winds. Many groups of people stayed together. So the few of us that were in the video server team, we sort of held together for several more companies, through several more iterations, to some extent, to a greater or lesser extent. Similarly, some of the people who stayed in the networking group beyond my time, they ended up at companies like Riverstone and others. And actually, there are still elements of them, up in the up in the wilds of Edinburgh and beyond, and various places, there's still some refugees still doing networking from the old DEC days.
What do you think? The big question is, what do you think DEC's legacy is? You obviously had a very intense and rewarding period there. What was its impact on you, its legacy, lasting legacy for you, and what is its legacy in the world? Two questions.
For me, I think this is going to sound terribly overblown. I don't mean it to sound, self-aggrandizing. I just mean it taught me the right thing to do, to tell right from wrong. Your parents taught you that when you were a kid, but what does that mean in engineering terms? Well, there's a particular, how much do you invest here and now, as opposed to for the future? Clearly, there's a compromise between spending too much now and going down the tubes before the future arrives versus not walling yourself into a dead-end alley. So that appreciation of how to structure, if you like, a product roadmap or a vision for a technology as to how it could span multiple years and generations and requirements that you don't even know yet. Some understanding of what an architecture is, some understanding that, an architecture may allow you to transition across multiple changes in requirements if you get the architecture right. That's something that I learned at DEC personally. So that's the biggest thing that I learned. Do the right thing, invest for the future, but don't over-invest for the future. Invest enough to make sure the future is protected. Of course, that's an art. It's not a science, but I learned that. To the world, well, everybody knows how to spell Ethernet, and that's DEC. That is DEC. The world is currently going through a revolution in terms of AMD and Intel, and actually the winner in all that is going to be ARM. And how did ARM come about? Well, ARM came about through some clever guys in Cambridge, but also they linked up with some guys at DEC, and they built strong ARM, and low power was a thing, and high frequency systems. So the transition from Intel Pentiums running at 100 megahertz and the DEC Alphas running at several hundred megahertz, that was the beginning of a transition that really underlies what we think of as computing today, in my opinion.
So still a legacy there to be had.
Yeah.
Absolutely right.
Big, fast systems, big, fast distributed systems. DEC was always about large distributed systems. So software, networks, time, email, what you think of as Facebook. I would argue there are precursors of that at digital. These large-scale internet systems, distributed systems in nature. I think DEC had a lot to offer there.
How was DEC? Because obviously IBM existed at the time.
IBM was mostly centralized, you see. IBM was mainframes, and you were connected to a mainframe, and you better like that. But DEC was all about how you connected lots of people and systems together. Maybe you were connecting the accounting system to the production system to the factory automation system. But those would all be DECs, faxes.